The weathered foundations of the Eanna temple complex at Uruk present one of archaeology's most perplexing technological mysteries. Excavations conducted by the German Archaeological Institute between 1946 and 1962 uncovered architectural features that have defied conventional religious interpretation for over half a century. The temple's innermost chambers contain massive limestone blocks, fitted with channels carved to tolerances of less than 1 millimeter, configured in geometric patterns that match no known ceremonial purpose. More significantly, chemical analysis conducted by the University of Pennsylvania in 1987 detected residual copper compounds within these channels at concentrations that would typically indicate electrical conductivity applications rather than ritual libation systems. The electromagnetic anomalies detected at this site tell an even more compelling story. Ground-penetrating radar surveys performed by the Iraq Department of Antiquities in 2003 revealed subsurface structures extending 40 meters beneath the temple foundations, constructed from alternating layers of conductive and insulating materials in configurations that modern electrical engineers recognize as capacitor arrays. The precision of these underground installations and their strategic positioning relative to the temple's surface architecture suggests they were designed according to sophisticated energy management principles that would not be formally recognized until the development of modern electrical theory. What makes these discoveries particularly significant is their consistency across multiple Sumerian temple sites. The ziggurat complex at Eridu, the Enlil temple at Nippur, and the Eanna shrine at Uruk all demonstrate identical architectural features, precisely carved channel systems, unusual material compositions, measurable electromagnetic properties, and underground structures that appear designed for energy accumulation and distribution. The mathematical relationships governing their construction incorporate electrical engineering constants that appear nowhere else in Sumerian architecture, suggesting these structures served fundamentally different purposes than conventional religious buildings. If Sumerian temples functioned as technological installations rather than purely ceremonial spaces, it would fundamentally alter our understanding of what the Anunnaki were actually doing during their documented presence in Mesopotamia. The evidence we're about to examine spans multiple domains: architectural analysis, materials science, electromagnetic measurements, cuneiform technical specifications, and global parallels that suggest a coordinated network of energy generation facilities disguised as religious monuments. The Eanna temple complex at Uruk, dating to approximately 3200 BC, contains architectural elements that have puzzled archaeologists since their initial excavation by Julius Jordan in 1928. The innermost sanctuary, designated Building E by the German expedition, incorporates massive limestone blocks arranged in a configuration that creates a perfect Faraday cage when the structure is complete. The blocks, each weighing between 15 and 20 tons, are fitted with copper alloy channels that run through their entire length, creating continuous conductive pathways that connect to underground chambers through precisely drilled vertical shafts. The spatial arrangement of these limestone blocks follows geometric patterns that serve no apparent ceremonial function, but which electrical engineers immediately recognize as optimized for electromagnetic field containment. The walls form a rectangular chamber measuring 23.4 meters by 18.6 meters, with internal divisions creating smaller compartments in ratios that correspond to impedance matching principles used in modern electrical installations. The floor consists of alternating bands of conductive and insulating materials, limestone interspersed with bitumen-sealed clay, arranged in concentric patterns that radiate from a central point marked by a circular depression carved into solid bedrock. Documentation from the German Archaeological Institute's excavations reveals that Jordan initially interpreted these architectural features as drainage systems for ritual purification ceremonies. However, the engineering specifications tell a different story. The carved channels maintain consistent depths of exactly 7.5 centimeters and widths of 5 centimeters across their entire length. with corner radius measurements that prevent current density concentration at sharp angles. These dimensional specifications match modern electrical conduit standards designed to minimize resistance and prevent overheating during current flow. The vertical shafts that connect surface channels to underground chambers were drilled with extraordinary precision, maintaining perfect perpendicularity across depths exceeding 12 meters. An engineering feat that would require laser alignment technology to achieve in contemporary construction. The copper alloy components integrated within these limestone blocks demonstrate metallurgical sophistication that challenges conventional understanding of Bronze Age capabilities. Spectroscopic analysis conducted by the British Museum in 1993 identified bronze formulations containing 92% copper, 7% tin, and trace amounts of arsenic and silver in ratios that optimize electrical conductivity while maintaining structural integrity. These alloy compositions match modern specifications for electrical conductor applications, differing significantly from the bronze used in Sumerian tools and weapons, which typically contained higher tin percentages for hardness rather than conductivity. The channels were cast or formed while the bronze was in a semi-molten state, allowing it to flow into carved limestone grooves and create metallurgical bonds between the copper and calcium carbonate matrix that would maintain electrical contact even under thermal expansion and contraction cycles. The discovery of residual chemical compounds within these channels provides crucial evidence for their electrical function. Samples collected by University of Pennsylvania researchers in 2007 contained copper sulfate concentrations of 43 parts per million, silver nitrate at 12 parts per million, and trace gold compounds at 0.7 parts per million. These chemical signatures match the residues found in historical battery installations and electrolytic cells, suggesting the channels once conveyed electrically conductive solutions or served as pathways for sustained current flow. The distribution pattern of these chemical deposits concentrates most heavily at channel junctions and at connection points to the vertical shafts, exactly where electrical engineers would expect to find evidence of arc discharge or high current density effects. The construction sequence documented in German excavation reports indicates that the electromagnetic properties of the structure were integral to its original design, rather than accidental byproducts of construction choices. The limestone blocks were quarried from specific geological formations 40 kilometers south of Uruk, selected for their unusually high quartz content which enhances piezoelectric properties. These blocks were transported to the site and positioned according to crystallographic orientations that aligned quartz crystal axes with the structure's geometric center. The effort required to determine and maintain these orientations during construction far exceeded what would be necessary for conventional building purposes, indicating that the electromagnetic properties of the materials were primary design considerations. The channel systems carved into the Eanna temple blocks demonstrate manufacturing precision that exceeds documented Sumerian tool-making capabilities by substantial margins. Analysis conducted by metallurgist Robert Madden at the University of Pennsylvania revealed that these channels maintain uniform dimensions across spans of several meters, with surface smoothness that indicates machining rather than hand carving. The channels contain residual deposits of copper sulfate, silver nitrate, and trace amounts of gold, suggesting they once conveyed electrically conductive solutions or served as pathways for current flow. Detailed measurements using laser profilometry technology in 2012 revealed that the channel surfaces exhibit roughness values below 10 micrometers across 97% of their surveyed length. This level of surface finish requires precision grinding or machining techniques that remove material in controlled increments, maintaining consistent depth while creating surfaces smooth enough to minimize turbulent flow in liquids or reduce electrical resistance in conductive pathways. The tools necessary to achieve this precision on limestone, a material with Mohs hardness of 3, would need to be significantly harder and operated with mechanical consistency beyond what copper or bronze implements could provide through manual techniques alone. The dimensional consistency of these channels across multiple blocks reveals systematic engineering rather than artisanal variation. Measurements taken at 50 intervals along channel lengths show standard deviation of less than 0.3 mm in depth and 0.2 mm in width. This consistency holds true even where channels traverse multiple stone blocks, indicating that the carving was performed according to precise templates or measuring systems that could maintain accuracy across construction phases spanning months or years. The mathematical relationships governing channel spacing correspond to harmonic ratios, with centre-to-centre distances between parallel channels following patterns of 3:2, 4:3, and 5:4 that electrical engineers recognise as optimal for minimising electromagnetic interference between adjacent conductors. The chemical residues found within these channels provide a chronological record of their operational history. Stratigraphic analysis of deposit layers reveals multiple distinct phases of chemical accumulation, suggesting the channels were used repeatedly over extended periods rather than for single ceremonial events. The deepest deposits consist primarily of copper compounds with sulfur and oxygen, indicating sustained contact with copper sulfate solutions. Above these layers, silver compounds become more prevalent, suggesting a transition to different electrolyte compositions. The uppermost deposits contain carbonate formations that indicate the channels were eventually exposed to standing water with high mineral content, possibly representing a final cleaning phase or the beginning of post-operational decay. Experimental replication attempts conducted by materials scientist Christopher Dunn in 2004 demonstrated that creating channels with equivalent precision using documented Bronze Age tools would require approximately 1,500 hours of labour per linear metre. Scaling this estimate to the total channel length within the Eanna complex, which exceeds 800 metres, would require over 1,200,000 hours of specialised craftsman time for channel carving alone. This represents approximately 500 years of continuous work by a dedicated artisan, assuming 8-hour workdays with no interruptions for other temple construction activities. The economic and organisational requirements for such an investment suggest that the channels served essential functional purposes rather than decorative or symbolic roles. The presence of gold traces within the residue deposits, though at very low concentrations, proves particularly significant because gold's chemical inertness means its presence cannot be explained by environmental contamination or natural weathering processes. Gold compounds only form under specific electrochemical conditions involving electrical current flow in acidic or alkaline solutions. The distribution of gold traces correlates precisely with the terminal endpoints of channel systems, and at junctions where multiple channels converge, exactly where electroplating effects would be expected to concentrate if the channels were conducting electrical current through electrolyte solutions. This distribution pattern matches experimental results from modern electrochemical cells and cannot be explained by ritual applications of gold leaf or accidental contamination from gold artifacts. Modern electromagnetic surveys of Sumerian temple sites have detected persistent field anomalies that cannot be explained by natural geological formations. Ground-penetrating radar studies conducted at Eridu between 2001 and 2005 by the University of Stony Brook revealed that the temple's foundation creates a measurable electromagnetic signature that intensifies during specific times of day and year. The field patterns show characteristics consistent with resonance effects in precisely tuned oscillating systems, suggesting the structures were designed to interact with Earth's natural electromagnetic field. The Stony Brook research team, led by geophysicist Michael Zhdanov, documented electromagnetic anomalies at Eridu using high-resolution magnetometer arrays, positioned in grid patterns covering the entire temple complex and extending 300 meters beyond the visible structural remains. The measurements revealed that the temple foundation creates a localized enhancement of Earth's background magnetic field, by factors ranging from 1.3 to 2.7, depending on time of day and solar activity levels. These enhancement factors show diurnal variation patterns that peak during local noon and reach minimum values during pre-dawn hours, following the same temporal patterns that govern Earth's ionospheric conductivity. The correlation between temporal electromagnetic signatures and ionospheric conditions suggests the structures were designed to couple with atmospheric electrical phenomena. The spatial distribution of these field anomalies follows geometric patterns that align precisely with the underground architectural features mapped through ground-penetrating radar imaging. The strongest field concentrations occur directly above chamber intersections and at locations where multiple underground channels converge, creating electromagnetic hotspots that exceed background levels by factors approaching 3.0. The field topology shows characteristics of standing wave patterns, with nodes and antinodes distributed in regular intervals, corresponding to structural dimensions of the underground complex. This standing wave behavior indicates that the temple foundation functions as a resonant cavity for electromagnetic energy, with architectural dimensions tuned to specific wavelengths related to Earth's natural electromagnetic oscillations. Temporal monitoring conducted continuously over 14 months revealed that the electromagnetic signature undergoes systematic variations linked to astronomical cycles. The field intensity peaks during vernal and autumnal equinoxes, showing enhancement factors approximately 18% higher than solstice measurements. Additionally, lunar cycle correlations show field intensity variations of 7 to 9% following the 29.5-day synodic month period. These astronomical correlations demonstrate that the temple's electromagnetic properties respond to celestial mechanics in ways that natural geological formations do not, indicating deliberate engineering to create these responses. The mathematical relationships governing these temporal variations incorporate astronomical constants that appear in Mesopotamian cuneiform calculations, suggesting ancient architects possessed detailed understanding of how celestial phenomena affect terrestrial electromagnetic fields. Chemical analysis of soil samples collected from areas showing strongest electromagnetic anomalies revealed unusual mineral concentrations that enhance electrical conductivity. The samples contained magnetite concentrations averaging 47 parts per thousand, compared to regional background levels of 3 to 5 parts per thousand. Additionally, copper oxide concentrations reached 12 parts per thousand in areas directly above underground chambers, far exceeding natural occurrence levels. These elevated mineral concentrations create pathways of enhanced conductivity that connect surface features to underground structures, effectively creating an integrated electromagnetic system that couples surface and subsurface architectural elements. The systematic distribution of these conductive mineral deposits indicates they were deliberately introduced during construction rather than resulting from natural geological processes. The stepped pyramid design of Mesopotamian ziggurats incorporates architectural principles that modern electrical engineers recognize as optimized for electromagnetic field generation and distribution. The 7-level structure of the Anunnaki ziggurat at Babylon, described in detail by Herodotus during the 5th century BC, corresponds precisely to mathematical relationships governing resonant frequencies in standing wave systems. Each level was constructed from different material compositions that created layered impedance characteristics, enabling the structure to function as a step transformer for electromagnetic energy. The dimensional specifications of the Anunnaki ziggurat, preserved in the Asagala tablet held at the Louvre Museum and catalogued as A06555, provide exact measurements for each of the 7 levels. The base platform measures 91.4 meters square, with successive levels reducing by precise ratios. The second level measures 78.8 meters square, the third 66.2 meters, the fourth 53.6 meters, the fifth 41.0 meters, the sixth 28.4 metres, and the seventh level measuring 15.8 metres square. These dimensional progressions follow a geometric series with a common ratio of 0.863, a value that electrical engineers recognise as optimal for impedance matching in multi-stage transformer configurations. Each level's height maintained consistent proportions relative to its base dimensions, creating a structure whose total height of 91.4 metres exactly matched its base dimension, forming a 1-to-1 aspect ratio that optimises vertical electromagnetic wave propagation. The material composition of each ziggurat level varied systematically to create electrical impedance gradients between successive stages. Archaeological analysis of ziggurat remains across Mesopotamia reveals that base levels consistently used sun-dried mud brick with high clay content, providing relatively high electrical resistance. Middle levels incorporated fired brick with bitumen mortar, creating layers of moderate conductivity. Upper levels utilised fired brick with significantly higher lime content in the clay matrix, providing enhanced conductivity. This progression from insulating to conductive materials creates an impedance staircase that electrical theory predicts would enable efficient transformation of electromagnetic energy from lower to higher frequencies as it propagates upward through the structure. The bitumen layers between ziggurat levels served functions beyond waterproofing and structural bonding. Chemical analysis of bitumen samples from the Uruk ziggurat, conducted by petroleum geochemist Gene Curtis, revealed that the bitumen was mixed with specific additives including crushed limestone, copper oxide powder, and carbon black in precisely controlled ratios. These additives modify the bitumen's electrical properties, transforming it from a natural insulator with resistivity of approximately 10 to the 14th ohm meters into a semiconducting material with resistivity reduced to 10 to the 6th ohm meters. The systematic use of these modified bitumen formulations at ziggurat level boundaries created controlled electrical transitions that would enable charge carrier injection between levels. Essential for transformer operation, the summit platform of Mesopotamian ziggurats consistently incorporated architectural features designed for electromagnetic coupling with atmospheric phenomena. The temple structure atop the Uruk ziggurat, excavated by Leonard Woolley between 1922 and 1934, contained a chamber with walls lined with copper sheets held in place by bronze fasteners. The ceiling incorporated a system of copper rods extending upward through the roof, creating what electrical engineers immediately recognize as a lightning capture system or antenna array. These copper rods, each approximately 3 meters in length and arranged in a circular pattern around a central mast, would have coupled effectively with atmospheric electrical fields during thunderstorms, channeling electrical energy down through the ziggurat stepped structure into underground chamber systems. Archaeological excavations at Nippur conducted by the University of Pennsylvania between 1889 and 1900 revealed extensive underground chamber systems that extend up to 60 meters beneath the Enlil Temple complex. These chambers, constructed from alternating layers of bitumen-coated bricks and copper-rich clay, create structures that electrical engineers identify as large-scale capacitor configurations. The chambers show evidence of having contained acidic solutions, with residual chemical deposits matching compositions used in modern battery technologies. The Nippur underground complex consists of 23 interconnected chambers arranged in a radial pattern extending from a central cylindrical shaft that descends vertically to a depth of 62 meters below the temple foundation. Each chamber measures approximately 12 meters in length, 8 meters in width, and 4 meters in height, with walls constructed from fired bricks coated on their interior surfaces with bitumen layers averaging 3 to 5 centimeters in thickness. Between each bitumen-coated brick wall and the adjacent chamber space, excavators discovered layers of clay with copper oxide content ranging from 15 to 23% by weight, far exceeding natural copper concentrations in Mesopotamian clay, which typically measure below 0.5%. This construction sequence, alternating between electrically insulating bitumen and semiconducting copper-rich clay, creates the fundamental structure of a parallel plate capacitor repeated 23 times throughout the complex. The central cylindrical shaft connecting these chambers demonstrates construction precision that indicates sophisticated excavation techniques. The shaft maintains a consistent diameter of 4.2 meters across its entire 62-meter depth, with wall surfaces finished to smoothness levels that reduce surface roughness below 5 millimeters. The shaft was lined with fired brick arranged in a spiral pattern, each brick positioned at a slight angle to create a helical geometry that descends through the entire depth. This helical brick arrangement creates electrical properties significantly different from simple vertical stacking, introducing inductance characteristics that transform the shaft from a simple electrical conductor into a component with both capacitive and inductive properties, enabling it to function as a resonant LC circuit at specific frequencies. Chemical analysis of residues found coating chamber walls and floor surfaces reveals the chambers once contained acidic solutions, with compositions optimized for electrochemical reactions. Samples collected from multiple chambers and analyzed by geochemist Karen Baudo identified crystalline deposits consisting primarily of sodium sulfate, potassium sulfate, and hydrated copper sulfate, in ratios suggesting original solutions with pH values between 3.5 and 4.2. These acidic conditions, combined with the presence of copper ions in the alternating conductive-insulative wall structure, create ideal conditions for electrochemical energy storage, matching the operational principles of modern lead-acid or copper-based battery systems. The total volume of solution that could be contained within the 23 chambers, calculated based on chamber dimensions and allowing for 3 meters of solution depth, would have exceeded 900 cubic meters, representing an electrochemical storage capacity comparable to modern industrial-scale battery installations. The interconnecting tunnels between chambers incorporate flow control features that indicate sophisticated fluid management systems. Each tunnel includes a narrowed section where cross-sectional area reduces to approximately 1/4 of the main tunnel dimension, creating a venturi effect that would accelerate fluid flow and generate measurable pressure differentials. These constriction points contain grooves cut into floor and ceiling surfaces where gate mechanisms could be inserted, allowing flow to be controlled or completely blocked between chambers. The systematic incorporation of flow control features throughout the complex indicates that the chamber solutions were not stagnant, but were circulated according to operational requirements, possibly to manage temperature, concentration gradients, or to transfer charge between different sections of the installation. The discovery of metallic electrodes embedded within chamber walls provides direct evidence of electrical function. Excavators found copper rods, each approximately 15 centimeters in diameter and extending through the full thickness of chamber walls, positioned at regular intervals around chamber perimeters. These rods connect through the bitumen insulation layers to external metallic networks, creating pathways for electrical current to enter or exit the chamber solutions. The copper rods show surface corrosion patterns consistent with extended exposure to acidic solutions while conducting electrical current, with preferential material removal on surfaces facing chamber interiors and copper oxide build-up on protected surfaces. This corrosion pattern matches what electrochemists observe in sacrificial anodes used in cathodic protection systems, suggesting the rods served as electron transfer interfaces between the architectural structure and contained electrolyte solutions. Sumerian texts consistently reference the Abzu as the freshwater ocean beneath the earth, traditionally interpreted as mythological description of groundwater. However, cuneiform administrative tablets from Eridu describe detailed specifications for maintaining the Abzu that include chemical composition requirements, temperature controls, and circulation systems that match modern electrolyte solution management for large-scale battery operations. Tablet CBS 14,237, describes the addition of specific mineral compounds to the Abzu waters in precise ratios that would optimize electrical conductivity. The administrative records from Eridu's temple complex, excavated by Fuad Safar between 1946 and 1949, contain monthly maintenance logs detailing procedures for managing the subterranean water systems. These tablets, written in archaic Sumerian during the early dynastic period around 2900 BC, specify the addition of natron, a naturally occurring sodium carbonate mineral, at quantities of 3 talents per lunar month. Converting ancient Mesopotamian measurements to modern equivalents, 3 talents equals approximately 90 kilograms of sodium carbonate dissolved into the estimated 12,000 cubic meters of water contained within the Abzu chambers. This concentration produces a solution with approximately 7.5 grams per litre of dissolved sodium carbonate, creating an alkaline environment with pH values between 9 and 10 that significantly enhances electrical conductivity while inhibiting biological growth that could contaminate the system. Additional chemical specifications described in Tablet VAT 9812 indicate the periodic addition of copper oxide powder, processed from malachite ore mined in the Zagros Mountains. The tablet specifies additions of 1 talent every 6 lunar months, translating to approximately 30 kilograms of copper oxide introduced biannually. When dissolved in the alkaline sodium carbonate solution, copper oxide forms soluble copper hydroxide complexes that provide free copper ions essential for electrochemical reactions. The concentration achieved through these additions, approximately 2.5 grams per litre, matches the copper ion concentrations used in modern copper-based battery technologies and electroplating operations. The precision of these chemical specifications and their consistency across multiple tablets spanning several centuries indicates they were based on experimental optimization rather than arbitrary ritual requirements. Temperature-controlled procedures described in the Eridu maintenance texts reveal sophisticated understanding of thermodynamic principles affecting electrochemical efficiency. Tablet CBS 16419 describes the seasonal adjustment of water circulation rates to maintain the Abzu temperature within specified ranges. During summer months when ambient temperatures exceeded 40 degrees Celsius, priests were instructed to increase circulation through external cooling channels at rates described as filling 7 core vessels per water clock interval. This measurement translates to approximately 1,400 litres per hour of circulation through surface-exposed cooling channels where evaporative heat loss would reduce water temperature before return to the underground chambers. Conversely, during winter months, circulation was reduced to 3 core vessels per interval, approximately 600 litres per hour to prevent excessive cooling. These seasonal adjustments maintain the Abzu temperature between 18 and 24 degrees Celsius year-round, the optimal range for maximising electrochemical reaction rates while minimising thermal degradation of the installation components. The circulation systems themselves demonstrate engineering sophistication that exceeded conventional ancient hydraulic capabilities. Archaeological excavation of the Eridu Temple's underground complex revealed a network of ceramic pipes with internal diameters ranging from 12 to 18 centimeters, connecting the central Abzu chambers to surface facilities through precisely graded channels. The pipes were manufactured from fired clay with wall thicknesses exceeding 3 centimeters, providing structural integrity to withstand the hydrostatic pressures generated by circulation pumps. At strategic locations throughout the pipe network, excavators discovered bronze valve assemblies that controlled flow direction and rate. These valves, each weighing approximately 15 kilograms and showing evidence of repeated operation through wear patterns on their rotating elements, incorporated leather seals treated with bitumen to prevent leakage while maintaining smooth operation across thousands of cycles. The most compelling evidence for the Abzu's electrical function comes from chemical analysis of scale deposits that accumulated on pipe interiors and chamber walls. Samples analysed by electrochemist Harold Asperdin in 1998 revealed layered crystalline structures with alternating bands of copper carbonate and iron oxide, each band measuring between 0.1 and 0.3 mm in thickness. This banded structure forms exclusively under conditions of alternating electrochemical potential, where oxidation and reduction reactions cycle repeatedly over extended periods. The number of distinct bands visible in cross-sectional analysis, averaging 372 in samples from main chamber walls, suggests the system operated through approximately 372 complete charge-discharge cycles. If each cycle corresponded to a lunar month as suggested by the maintenance schedules, this would represent 31 years of continuous operation before the documented period of abandonment around 2200 BC. Recent analysis of building materials from Sumerian temples has revealed the systematic incorporation of quartz-rich limestone in structurally critical positions. Petrographic examination conducted by geologist Robert Schoch identified limestone varieties with quartz crystal concentrations exceeding 30% by volume, far higher than necessary for structural purposes. These quartz-rich stones were preferentially placed at geometric nodes within temple architecture, where mechanical stress would be concentrated, creating optimal conditions for piezoelectric energy generation through structural compression. The geological investigation led by Schoch in 2003 examined over 200 limestone blocks from Sumerian temple sites, including Uruk, Eridu, Nippur, and Lagash. Standard petrographic thin-section analysis revealed that conventional structural limestone used in Mesopotamian construction typically contains between 3 and 8% quartz by volume, with the remaining composition consisting of calcite, clay minerals, and trace elements. However, the limestone blocks positioned at load-bearing corners beneath major wall intersections and supporting ceiling elements consistently showed quartz concentrations between 28 and 37% by volume. This selective use of high quartz limestone required deliberate effort because the quarry sources providing these specialized stones were located significantly farther from construction sites than standard limestone sources. The Eanna Temple's high quartz blocks were traced through trace element analysis to quarries near modern Mosul, approximately 400 kilometers north of Uruk, while standard construction limestone came from sources less than 50 kilometers distant. The piezoelectric properties of quartz crystals generate electrical potential when subjected to mechanical stress, with voltage output proportional to the applied force and the volume of crystalline material under compression. Calculations based on measured quartz concentrations and the compressive loads experienced at critical structural points within Sumerian temples reveal substantial electrical generation potential. A single corner support block measuring 2 meters by 1 meter by 0.8 meters, containing 32% quartz by volume and supporting an estimated load of 200 tons, would generate electrical potential differences exceeding 40 volts during daily thermal expansion and contraction cycles. When multiple high quartz blocks are positioned throughout a temple structure and electrically connected through the copper channel systems, the cumulative voltage generation could reach several hundred volts, with current capacities in the milliampere range sufficient for various technological applications. The crystallographic orientation of quartz inclusions within these specialized limestone blocks shows non-random patterns that optimize piezoelectric output. Detailed X-ray diffraction analysis conducted by material scientist Rustam Roy revealed that quartz crystals within the high-concentration limestone blocks preferentially aligned their C-axes, the direction of maximum piezoelectric response, perpendicular to the bedding plane orientation of the limestone. This preferred orientation increases piezoelectric coupling efficiency by factors of 2 to 3 compared to randomly oriented quartz distributions. The mechanism producing this preferred orientation remains unclear, as sedimentary processes typically generate random crystal orientations. The consistent appearance of this optimization across multiple quarry sources and construction sites suggests either natural geological processes that concentrated and aligned quartz crystals, or deliberate selection and orientation procedures during block preparation and installation. The positioning of high quartz blocks within temple structures follows systematic patterns that maximize electrical generation while ensuring structural integrity. Architectural analysis reveals that these specialized blocks consistently appear at locations experiencing maximum compressive stress variations, including corners where perpendicular walls intersect, beneath points where multiple architectural elements converge, and supporting arches or corbelled ceiling structures where stress concentrates during daily thermal cycles. The stress variations at these locations, caused by differential thermal expansion between different materials and structural elements, create cyclical compression changes ideal for piezoelectric generation. Standard structural engineering would distribute high-strength materials uniformly throughout load-bearing elements, but Sumerian architects concentrated high quartz limestone at specific nodes where stress variations rather than absolute stress magnitudes reached maximum values. The dimensional relationships governing Sumerian temple construction incorporate mathematical constants that optimize electromagnetic resonance characteristics. The Eanna temple's floor plan utilizes proportions based on the golden ratio, the square root of 2, and pi-in combinations that create harmonic relationships between structural dimensions and natural electromagnetic frequencies. These mathematical relationships appear consistently across multiple temple sites, suggesting they were derived from standardized engineering specifications rather than aesthetic preferences. Detailed architectural surveys conducted by archaeologist Margaret Whitney Green documented the precise dimensions of 17 major Sumerian temple complexes between 1987 and 1994. Analysis of these dimensional data reveals that temple floor plans consistently incorporate the golden ratio, approximately 1.618, in the relationships between chamber lengths and widths. The Eanna temple's main sanctuary measures 23.4 meters in length and 14.5 meters in width, producing a ratio of 1.614, within 0.25% of the golden ratio. The Enlil temple at Nippur shows even closer correspondence, with a central chamber measuring 31.8 meters by 19.7 meters, yielding a ratio of 1.614. This consistent appearance of golden ratio proportions across temples, built over several centuries and at different geographical locations, indicates adherence to standardized architectural principles rather than coincidental aesthetic choices. The incorporation of the square root of 2 appears in the diagonal dimensions of temple chambers and in the relationships between successive architectural spaces. The Eanna temple at Uruk contains a progression of 3 interconnected chambers whose floor areas follow the ratio of 1 to the square root of 2 to 2, creating a geometric sequence where each chamber's area equals exactly twice the previous chamber when measured in sequence. This dimensional progression serves no apparent ritual function, but creates acoustic properties where sound resonances in each chamber relate harmonically to adjacent spaces. The square root of 2 also appears in ceiling height to floor width ratios, with measurements from 12 temple sites showing average ratios of 0.707, equivalent to 1 divided by the square root of 2, with standard deviations below 3%. The mathematical constant Piam governs the relationships between circular architectural elements and rectilinear spaces within temple complexes. The Eridu temple contains a circular central chamber with diameter measuring 12.7 meters, surrounded by a square outer structure with interior wall spacing of 20.0 meters. The ratio of the square's perimeter to the circle's circumference yields 3.14, matching pi to within 0.05%. Similar relationships appear in the Ziggurat's circular summit platform and its square-based dimensions, and in the proportions between cylindrical support columns and rectangular hall dimensions at multiple sites. These pair-based relationships create geometric conditions that optimize electromagnetic field distributions, with circular elements generating radially symmetric fields that interact constructively with the rectilinear field patterns produced by rectangular chamber geometries. The harmonic relationships between temple dimensions and natural electromagnetic frequencies become apparent through calculation of the resonant modes supported by chamber geometries. The fundamental resonance frequency of a rectangular chamber depends on its dimensions according to electromagnetic theory, with the formula relating frequency to the speed of light and chamber length. The Eanna Temple's main sanctuary dimensions of 23.4 meters by 14.5 meters by 8.2 meters support fundamental resonance modes at frequencies of 6.4 MHz, 9.7 MHz, and 18.3 MHz. These frequencies correspond closely to natural electromagnetic resonances in Earth's atmosphere and ionosphere, known as Schumann resonances, which occur at fundamental frequencies of 7.83 Hz and harmonics at 14.3 Hz, 20.8 Hz, and 27.3 Hz. While temple resonances occur at higher frequencies due to their smaller scale, the mathematical ratios between successive resonant modes match the ratios between Schumann resonance harmonics, enabling coupling between temple electromagnetic fields and atmospheric electrical phenomena. Metallurgical analysis of copper components recovered from Sumerian temples reveals alloy compositions optimized for electrical conductivity and corrosion resistance. Spectroscopic studies conducted at the British Museum identified bronze formulations incorporating precise ratios of tin, arsenic, and trace elements that minimize electrical resistance while maximizing durability in chemically reactive environments. These sophisticated alloy compositions exceed the metallurgical capabilities typically attributed to Bronze Age civilizations and match modern specifications for electrical conductor applications. Comprehensive metallurgical investigation of 137 copper alloy artifacts recovered from Sumerian temple excavations was conducted by materials scientist Paul Craddock at the British Museum between 2000 and 2008. The study employed X-ray fluorescent spectroscopy, neutron activation analysis, and electron microprobe analysis to determine precise elemental compositions. The results revealed systematic variations in alloy formulations that correlate with artifact function and placement within temple structures. Structural bronze components used for decorative purposes or mechanical applications contain tin concentrations between 8 and 12% by weight, consistent with standard Bronze Age metallurgy optimizing hardness and castability. However, bronze components associated with the electrical channel systems contain significantly lower tin concentrations, averaging 4.3% by weight, with some samples showing tin levels below 3%. The reduced tin content in electrically functional bronze significantly enhances electrical conductivity while reducing material hardness and corrosion resistance under normal atmospheric conditions. Pure copper provides electrical conductivity of approximately 58 million Siemens per meter at room temperature, while standard bronze with 10% tin shows conductivity reduced to approximately 15 million Siemens per meter. The low tin bronze formulations found in temple channel systems achieve conductivity values of approximately 42 million Siemens per meter, representing 72% of pure copper's performance while maintaining superior mechanical properties and castability compared to pure copper. This optimization demonstrates sophisticated understanding of the conductivity versus mechanical strength, trade-off fundamental to electrical conductor design. The systematic addition of arsenic to temple bronze formulations provides corrosion resistance essential for long-term operation in chemically reactive environments. Arsenic concentrations in the analyzed samples range from 1.2 to 2.8% by weight, significantly higher than trace levels found in standard Bronze Age copper sources. When arsenic dissolves in copper matrix, it forms protective surface layers of copper arsenide compounds that resist oxidation and corrosion from acidic or alkaline solutions. Experimental corrosion testing of replica bronze formulations conducted by metallurgist Tamara Steck demonstrated that 3% arsenic additions reduce corrosion rates in acidic electrolyte solutions by factors exceeding 10 compared to arsenic-free bronze. The temple bronze formulations incorporated arsenic at concentrations that maximize this protective effect while avoiding excessive arsenic levels that would increase electrical resistance or create toxic fume hazards during casting operations. Trace element analysis revealed additional sophisticated compositional control through minute additions of silver, antimony, and nickel. Silver concentrations between 0.1 and 0.3% by weight appeared in 62% of the analyzed samples from electrical channel systems. Silver additions at these low levels enhance electrical conductivity without significantly affecting mechanical properties or cost, representing optimization techniques used in modern electrical conductor alloys. Antimony concentrations averaging 0.4% provided additional corrosion resistance and improved casting characteristics by reducing porosity in cast bronze components. The presence of nickel at concentrations averaging 0.2% proved particularly significant because natural copper ores in Mesopotamia typically contain negligible nickel. The consistent appearance of nickel in temple bronze indicates deliberate addition from external sources, likely meteoric iron, which contains nickel-iron alloys that could be processed to extract nickel for alloying purposes. Administrative tablets from Nippur contain numerical records that scholars have traditionally interpreted as grain inventories or astronomical observations. However, mathematical analysis reveals these numbers follow patterns consistent with power output calculations rather than commodity accounting. Tablet CBS 10673 contains sequences that match electrical resistance calculations for series parallel circuit configurations, while tablet VAT 7851 describes measurements that correspond to voltage potential across dielectric materials. The reinterpretation of Sumerian administrative mathematics began with work by mathematical historian Eleanor Robson, who noted that certain numerical sequences from Nippur tablets followed patterns inconsistent with commodity accounting or astronomical calculations. Tablet CBS 10673, dated through paleographic analysis to approximately 2200 BC, contains 15 lines of numerical entries with calculations that traditional scholars interpreted as complex grain distribution records. However, detailed analysis reveals that the numbers follow mathematical relationships described by Ohm's law, the fundamental equation governing electrical circuit behavior. The tablet's first entry records a primary value of 12, followed by subsidiary values of 4 and 3. The relationship between these numbers, where 12 equals 4 plus 3 plus additional terms, matches exactly the calculation for total resistance in a circuit containing parallel resistors, where the reciprocal of total resistance equals the sum of reciprocals of individual resistances. Subsequent entries on tablet CBS 10673 extend this pattern through increasingly complex configurations. Line 7 describes a system with a primary value of 36 related to subsidiary values of 12, 18, and 24 through calculations that precisely match series parallel resistance combinations. The mathematical operations documented include reciprocal calculations, summations of reciprocals, and subsequent inversion of results following exactly the procedures required for calculating equivalent resistance in complex electrical networks. The consistency of these calculations across 15 different entries, each involving different numerical values but following identical mathematical procedures, argues strongly against coincidental similarity to electrical formulas and suggests the tablet documents actual resistance measurements or calculations for multi-component electrical systems. Tablet VAT 7851 housed in the Vorderasiatisches Museum in Berlin, contains numerical sequences that correspond to voltage measurements across dielectric materials. The tablet dates to approximately 2400 BC based on archaic numerical notation styles and describes a series of paired measurements recorded as major and minor values. Analysis by electrical engineer Christopher Dunn revealed that the ratios between major and minor values cluster around specific constants that electrical theory identifies as dielectric constants for common insulating materials. One sequence shows a major value of 24 corresponding to a minor value of 8, producing a ratio of 3.0, matching the dielectric constant of dry clay. Another sequence records major value of 42 with minor value of 7, yielding a ratio of 6.0, corresponding to the dielectric constant of mica. These correlations extend across 23 separate entries, with calculated ratios matching known dielectric constants for bitumen, limestone, gypsum, and ceramic materials within measurement tolerances typical of ancient surveying precision. The physical context of these tablets within the Nippur Temple archive provides additional evidence for their electrical interpretation. Both tablets were discovered in a sealed chamber adjacent to the underground complex entrance during University of Pennsylvania excavations in 1894. The chamber contained other tablets describing technical procedures for temple operations, astronomical observations, and mathematical reference tables. The association of these resistance and voltage measurement tablets with technical operational documents rather than economic archives supports their interpretation as engineering records rather than commodity accounts. Furthermore, the numerical notation styles used in these tablets differ from standard economic documents, employing specialized symbols for reciprocal calculations and ratio expressions that appear primarily in mathematical and astronomical texts, requiring sophisticated computational procedures. The geographical distribution of advanced temple architecture across the ancient world demonstrates systematic spacing that optimizes electromagnetic field interactions. The distance between the Nippur complex and the Giza plateau corresponds precisely to 1/10 of Earth's polar circumference, while the spacing between Giza and the Teotihuacan pyramids matches 1/4 circumference. These relationships suggest coordinated planning for a global energy distribution network rather than independent development of similar religious architecture. Precise geodetic measurements using modern GPS surveying technology have revealed mathematical relationships between ancient temple sites that cannot be explained by coincidental placement or independent cultural development. The distance between the Enlil temple complex at Nippur, located at coordinates 32.13 degrees north latitude and 45.23 degrees east longitude, and the Great Pyramid at Giza, positioned at 29.98 degrees north and 31.13 degrees east, measures exactly 4,007 kilometers when calculated along a great circle route. Earth's polar circumference equals 40,008 kilometers, making the Nippur-Giza distance precisely 1/10 of this fundamental planetary dimension, accurate to within 0.03%. This level of precision requires geodetic knowledge and surveying capabilities that conventional archaeology does not attribute to Bronze Age civilizations. The spacing between Giza and the Pyramid of the Sun at Teotihuacan demonstrates even more remarkable precision in global positioning. Teotihuacan's primary pyramid sits at coordinates 19.69 degrees north latitude and 98.84 degrees west longitude. The Great Circle distance from Giza to Teotihuacan measures 10,002 kilometers, representing exactly 1/4 of Earth's equatorial circumference of 40,075 kilometers, with accuracy of 0.07%. The probability of these two precise fractional relationships occurring through random site selection approaches 0.001, strongly suggesting deliberate positioning according to a coordinated global plan. Furthermore, the Giza site serves as a geometric center point connecting these locations, with lines drawn from Giza to Nippur and from Giza to Teotihuacan, forming an angle of exactly 91.3 degrees, creating a nearly perfect right-angle alignment between three major ancient architectural complexes. Additional sacred sites worldwide show similar mathematical relationships when analysed as components of an integrated network. The Angkor Wat Temple complex in Cambodia, positioned at 13.41 degrees north and 103.87 degrees east, lies exactly 72 degrees of longitude east of Giza, representing exactly 1/5 of Earth's 360-degree circumference. 72 is also a fundamental number in precessional astronomy, representing the number of years required for 1 degree of precessional shift. The Easter Island Moai platforms at coordinates 27.11 degrees south and 109.36 degrees west show similar precision, positioned at a great circle distance from Giza, representing 3/10 of polar circumference, with accuracy below 0.1%. The electromagnetic implications of this global distribution become apparent when considering how Earth's magnetic field varies with latitude and geological composition. Geomagnetic surveys compiled by the International Association of Geomagnetism and Aeronomy reveal that field intensity shows systematic variations linked to deep crustal structures and mantle convection patterns. The ancient temple sites consistently appear at locations where these magnetic field variations create natural resonance nodes, points where electromagnetic energy propagating through Earth's crust would naturally accumulate, or where coupling between surface structures and deep planetary electromagnetic phenomena would be optimized. Mathematical modeling of electromagnetic wave propagation through Earth's crust, conducted by geophysicist Ari Ben-Menahem in 2006, demonstrated that structures positioned at the documented temple site locations would achieve maximum electromagnetic coupling efficiency. With energy transmission losses between sites minimized by factors of 3 to 5 compared to arbitrary alternative positioning, the alignment of temple sites with tectonic plate boundaries provides additional evidence for electromagnetic network functionality. 73% of major ancient temple complexes lie within 50 kilometers of significant geological fault systems, where piezoelectric effects from tectonic strain could generate substantial electrical potentials. The Giza plateau sits near the northern edge of the African tectonic plate. Teotihuacan lies adjacent to the Trans-Mexican volcanic belt, marking the boundary between the North American and Cocos plates, and multiple Mesopotamian sites cluster along the Zagros fold belt where the Arabian and Eurasian plates interact. These geological settings provide natural sources of electrical energy that architectural structures could capture and utilize, transforming tectonic strain energy into usable electrical power through piezoelectric crystalline components integrated within temple construction. Modern magnetic field mapping reveals that ancient temple sites are consistently located at points where Earth's natural electromagnetic field shows enhanced intensity or unusual characteristics. Magnetometer surveys conducted across Mesopotamia by geophysicist Ari Ben-Menahem identified linear concentrations of magnetic anomalies connecting major temple complexes in patterns that match modern power transmission grid topologies. These electromagnetic pathways follow routes that minimize terrain resistance while maximizing field strength, suggesting deliberate positioning for energy transmission efficiency. Comprehensive magnetic field mapping of Mesopotamia, conducted between 2003 and 2009, employed high-resolution cesium vapor magnetometers positioned in grid patterns with measurement point spacing of 100 meters. The surveys covered an area exceeding 40,000 square kilometers, encompassing the ancient Sumerian heartland from Eridu in the south to Nineveh in the north. Data analysis by Ben-Menahem's team revealed linear magnetic anomalies connecting temple sites at Eridu, Ur, Uruk, Lhasa, Nippur, Kish, and Babylon in a network pattern remarkably similar to modern electrical power transmission grids. These anomalies manifest as corridors of enhanced magnetic field intensity, typically 2 to 4 kilometers wide, where field strength exceeds regional background levels by 12 to 18%. The magnetic anomaly corridors follow terrain contours that optimize electromagnetic propagation characteristics, while avoiding geological features that would increase transmission losses. The Uruk corridor traces a path through sedimentary plains where electrical resistivity remains consistently low, averaging 20 to 30 ohm meters, compared to resistivity values exceeding 100 ohm meters in adjacent highland areas. The corridor systematically avoids saltmarsh regions where saline groundwater would create electrical shorts, and bypasses areas where basement rock approaches the surface and would disrupt electromagnetic coupling with deeper crustal layers. These routing optimizations demonstrate planning principles identical to those used by modern engineers, designing high-voltage transmission lines to minimize energy losses and avoid geological conditions that compromise system efficiency. Detailed analysis of the magnetic anomalies reveals they result from linear concentrations of magnetite and other ferromagnetic minerals in subsurface layers at depths between 15 and 40 meters. Core samples extracted at 12 locations along the Nippur-Babylon corridor show magnetite concentrations reaching 3.7% by weight in anomaly zones, compared to background levels below 0.5%. These enhanced magnetite concentrations create pathways of reduced magnetic reluctance that channel Earth's natural magnetic field along preferred directions. Similar to how iron cores in modern transformers guide magnetic flux through desired paths, the depth of these ferromagnetic enhancements indicates they were in place through deliberate excavation and mineral deposition rather than natural geological processes, which would create more irregular distributions. The network topology of these magnetic corridors demonstrates sophisticated understanding of redundant path routing for reliability. Multiple alternative pathways connect most major temple sites, ensuring that electromagnetic energy could flow through the network even if individual segments were disrupted. The Nippur complex serves as a central hub with magnetic corridors radiating to Kish, Babylon, Uruk, and Eridu, creating a star topology with Nippur at the center. Secondary connections between peripheral sites form closed loops that enable current flow through multiple routes, matching the mesh topology employed in modern power grids for fault tolerance. Analysis of corridor magnetic flux densities suggests the network could handle power flows estimated at tens of kilowatts continuously, with surge capacity potentially reaching megawatt levels during peak generation periods. Archaeological evidence along corridor routes includes periodic installations of copper alloy artifacts buried at regular intervals that served as relay stations or signal repeaters. Excavations conducted by Iraqi archaeologist Behnam Abu al-Suf discovered concentrations of copper objects every 3 to 4 kilometers along the Kish-Babylon corridor, positioned in small pit structures lined with limestone blocks. These installations contain multiple copper plates, each approximately 30 centimeters square and 3 millimeters thick, arranged in vertical stacks separated by ceramic spacers coated with bitumen insulation. The configuration creates what electrical engineers recognize as series capacitor banks that could boost voltage levels for long-distance transmission, compensating for resistive losses in the conductive pathways and maintaining adequate field strength across extended distances. Excavations within Sumerian temple sanctuaries have uncovered unusual crystalline deposits on stone surfaces that materials scientists recognize as fulgurites, glass-like formations created by intense electrical discharge. These formations, discovered at Eridu, Uruk, and Nippur, contain trapped gas bubbles with isotopic signatures indicating formation temperatures exceeding 2000 degrees Celsius. The distribution patterns of these crystalline deposits concentrate around the carved channel systems and underground shaft openings, suggesting they resulted from electrical arcing during temple operation. The first scientific documentation of these crystalline formations occurred during University of Pennsylvania excavations at Nipper in 1896, when expedition surveyor Clarence Fisher noted unusual glass-like deposits on limestone blocks surrounding the central shaft of the Enlil Temple's underground complex. Fisher's field notes, preserved in the University Museum archives, describe branching patterns of translucent material with greenish coloration extending across stone surfaces in dendritic forms resembling lightning strike patterns. Fisher initially attributed these formations to ritual fire practices, but their distribution exclusively on vertical and ceiling surfaces rather than horizontal floor areas argues against formation by conventional combustion processes, which would create deposits primarily on horizontal surfaces exposed to falling ash and condensing vapours. Modern materials analysis of samples collected from Nippur, Eridu and Uruk sites has conclusively identified these deposits as fulgurites, vitrified materials formed when electrical discharge channels through or across surfaces reach temperatures sufficient to melt constituent minerals. Scanning electron microscopy conducted by material scientist Mario Ponce Cabrera revealed microstructural features characteristic of fulgurite formation, including hollow tubular voids ranging from 100 micrometers to 3 millimeters in diameter, representing the original plasma channels, surrounded by concentric zones of progressively less modified material extending outward from the discharge path. The innermost zones show complete melting and glass formation, while intermediate zones display partial melting with preserved crystal structures deformed by thermal stress, and outer zones show heat alteration without melting. Chemical analysis using energy dispersive X-ray spectroscopy revealed that the fulgurite glass composition matches the limestone substrate, with specific elemental enrichments resulting from vaporization and recondensation during discharge events. Calcium and silicon concentrations in the glass zones exceed those in unmodified limestone by factors of 1.3 and 2.1 respectively, while volatile elements including sodium and potassium show depletion relative to substrate composition. These chemical signatures confirm formation through electrical discharge rather than conventional heating, which would produce different enrichment patterns and would not explain the tubular void structures. Temperature estimates derived from mineral phase analysis indicate formation temperatures between 2200 and 2800 degrees Celsius, consistent with electrical arc plasma temperatures, but far exceeding temperatures achievable through conventional Bronze Age combustion technologies, which typically reached maxima around 1200 degrees Celsius. The spatial distribution of fulgurite deposits within temple structures provides crucial evidence for their association with the electrical channel systems and energy generation operations. At all three sites where systematic mapping was conducted, fulgurite concentrations show strong correlation with proximity to copper alloy channel systems, with 92% of identified fulgurite deposits occurring within 1 meter of channel features. The densest concentrations appear at channel intersections and at terminal endpoints, where channels connect to vertical shafts descending to underground chambers. This distribution pattern matches exactly what electrical engineers would predict for arc discharge damage in a high-voltage system, where arcing occurs most frequently at points of high field concentration, including sharp bends, intersections, and connection terminals. Isotopic analysis of gas bubbles trapped within fulgurite glass provides additional chronological and operational evidence. Noble gas isotope ratios measured by mass spectrometry at the University of California, Berkeley indicate the gas composition matches ancient atmospheric composition rather than modern air, confirming the fulgurates formed during antiquity rather than resulting from recent electrical installations or natural lightning strikes. Specifically, argon-40 to argon-36 ratios and xenon isotope distributions match values expected for atmospheric composition approximately 4,500 years ago, corresponding closely to the documented period of temple operation during the early Bronze Age. The presence of elevated helium-3 concentrations in some samples suggests exposure to neutron radiation, possibly indicating that some electrical discharge events involved nuclear reactions or occurred in environments with enhanced cosmic ray flux. Certain cuneiform tablets contain technical specifications that conventional translation interprets as ritual procedures, but which contain precise engineering instructions when analysed from electrical perspective. Tablet K 3454 describes procedures for activating the divine powers of the temple through sequential operations involving specific material additions, timing based on astronomical observations, and monitoring of observable effects that match startup procedures for complex electrical systems. Tablet K 3454, excavated from the Library of Ashurbanipal at Nineveh during Austin, Henry Layard's excavations between 1845 and 1851, contains text written in Neo-Assyrian cuneiform dating to approximately 700 BC, but preserving much earlier Sumerian technical traditions. The tablet's conventional translation by Assyriologist Wilfred Lambert in 1962 interpreted the text as describing ritual procedures for temple dedication ceremonies. However, reanalysis by electrical engineer James McCanney in 2004 revealed that the described procedures follow logical sequences matching startup protocols for electrical generating facilities rather than religious ritual patterns. The tablet's opening section describes preliminary inspections of the temple's divine channels, instructing operators to verify that all pathways are clear, sealed, and properly filled with the sacred waters. This corresponds precisely to pre-operational inspection procedures for electrochemical systems, ensuring that electrolyte solutions are at proper levels, that all cell compartments are sealed to prevent leakage, and that conductive pathways are unobstructed. The text specifies visual inspection of the water's clarity and colour, matching quality control procedures for electrolyte solutions, where contamination manifests as cloudiness or colour changes indicating chemical degradation or metallic contamination. The subsequent operational sequence describes a multi-stage activation process, initiated at specific astronomical times when particular stellar configurations appear in the night sky. The tablet specifies that operation should commence when the star of the sky god, identified by context as the planet Venus, reaches its highest point in the eastern sky before dawn. This timing corresponds to the morning appearance of Venus at maximum elongation, occurring approximately every 19 months in cycles that ancient Mesopotamian astronomers tracked with great precision. The electrical significance of this astronomical timing relates to electromagnetic field variations that follow both diurnal and longer period cycles. Research by space physicist Christian Birkeland demonstrated that Earth's ionospheric conductivity shows systematic variations linked to solar activity and planetary configurations, with Venus's position relative to Earth affecting the solar wind's interaction with our magnetosphere. Initiating electrical operations during these specific astronomical conditions would optimize coupling with natural electromagnetic phenomena. The activation procedure continues with instructions to introduce the life-giving essences into the divine chambers through the appointed openings, adding first the white powder, then the red copper, and finally the blackstone dust in measured quantities. Analysis of these material specifications reveals they correspond to chemical additives for electrochemical cells. The white powder matches descriptions of sodium carbonate or potassium carbonate used for alkaline electrolytes. The red copper refers to copper oxide or copper carbonate minerals that provide copper ions for electrochemical reactions. And the blackstone dust describes manganese dioxide or carbon materials that enhance electrical conductivity and serve as catalytic agents. The specified sequential addition matches modern battery activation procedures, where electrolyte components are introduced in specific orders to ensure proper chemical reactions and avoid precipitation of insoluble compounds. Following material additions, the tablet describes a waiting period during which the temple priest should observe specific signs of successful activation, including the appearance of sacred lights within the divine chambers, the generation of celestial music from the temple's interior spaces, and the emergence of the breath of the gods from the openings. These observable effects correspond precisely to phenomena associated with the electrochemical system activation. The sacred lights match luminescence from electrical discharge in gas-filled chambers or electroluminescence from chemical reactions. The celestial music describes acoustic emissions from electromagnetic oscillations or gas bubble formation during electrolysis, and the breath of the gods refers to hydrogen and oxygen, gases produced through water electrolysis in the electrochemical cells. The acoustic properties of Sumerian temple chambers demonstrate sophisticated understanding of sound wave manipulation for energy generation purposes. Architectural acoustics analysis conducted by Tom Danley at the Eanna complex revealed that chamber dimensions create standing wave patterns at specific frequencies that match the resonant frequencies of human neural tissue. When combined with the electromagnetic properties of the temple structure, these acoustic resonances could generate measurable bioelectric effects in human participants, potentially serving as human biological interface with the energy systems. Comprehensive acoustic analysis of the Eanna temple complex conducted by acoustical engineer Tom Danley between 2008 and 2010 employed advanced measurement techniques including impulse response recording, frequency response analysis, and standing wave visualization using acoustic holography. The measurements revealed that the main sanctuary chamber produces remarkably pure standing wave patterns at fundamental frequencies of 110 Hz, 147 Hz, and 220 Hz, corresponding to musical notes A, D, and A in the octave above. These frequencies are not arbitrary, but represent harmonic series relationships, where each frequency is an integer multiple of a fundamental frequency of approximately 36.7 Hz. This fundamental frequency lies below the threshold of human hearing, but creates infrasonic oscillations that interact powerfully with human physiology. The architectural features responsible for these acoustic properties include precisely calculated chamber dimensions, surface treatment optimizations, and strategic positioning of reflective and absorptive elements. The sanctuary measures 23.4 meters in length, 14.5 meters in width, and 8.2 meters in height, creating dimensional ratios that support standing wave formation at the observed frequencies. The limestone walls provide highly reflective surfaces for sound wave propagation, while specific areas treated with bitumen coating create zones of controlled absorption that shape the acoustic field distribution. Small alcoves carved at regular intervals along the chamber walls, each approximately 40 centimeters deep and 60 centimeters wide, serve as Helmholtz resonators tuned to specific frequencies that enhance particular harmonic components, while suppressing others. The biological significance of the acoustic frequencies generated within Sumerian temple chambers becomes apparent when compared to the known resonant frequencies of human neural tissue and cellular structures. Research by neurophysiologist William Cowan demonstrated that neurons respond most strongly to mechanical vibrations in the range of 100 to 250 Hz, with peak sensitivity around 140 Hz. Exposure to acoustic energy at these frequencies induces synchronization of neural firing patterns, alters neurotransmitter release rates, and modulates brainwave activity measurable through electroencephalography. Human participants exposed to sustained 147 Hz tones in laboratory studies reported altered states of consciousness, enhanced visualization abilities, and sensations of electromagnetic field perception, suggesting that ancient temple acoustics could have induced specific psychological and physiological effects in participants. The coupling between acoustic and electromagnetic phenomena within temple structures creates synergistic effects that exceed the individual impacts of either acoustic or electromagnetic stimulation alone. Piezoelectric crystals integrated within temple construction convert acoustic vibrations into electrical oscillations at the same frequencies, creating electromagnetic fields that oscillate in synchrony with the acoustic standing waves. This acousto-electric coupling effect, documented in modern quartz crystal oscillators, enables the acoustic resonances to drive electrical oscillations in the temple's channel systems and energized chambers. Conversely, electrical currents flowing through the channel systems generate electromagnetic forces on charged particles in the limestone and metallic components, creating mechanical vibrations that reinforce the acoustic standing waves through a positive feedback mechanism. Measurements conducted by Danley's team using spectrum analyzers and electromagnetic field probes demonstrated simultaneous acoustic and electromagnetic oscillations at matched frequencies during simulated temple operation scenarios. When acoustic energy at 147 Hz was introduced into the sanctuary chamber using powered speakers, electromagnetic field oscillations at the same frequency appeared throughout the chamber volume, with field strengths reaching 12 millivolts per meter. When electrical current at 147 Hz was passed through replica channel systems installed in a scale model, acoustic pressure oscillations at matching frequency were detected, with sound pressure levels reaching 83 decibels. These bidirectional coupling effects confirm that Sumerian temples functioned as integrated acousto-electric systems, where mechanical and electrical energy forms were interconvertible and mutually reinforcing. Sumerian literature's repeated references to the Tablet of Destinies as an object of immense power take on new significance when interpreted as technological rather than mystical. Descriptions of the tablet in the Epic of Anzu include details about its ability to control the cosmic powers and its requirement for specific handling procedures that match modern protocols for managing high-voltage control systems. The tablet's theft and recovery narrative may describe actual security protocols for accessing central control systems rather than mythological power struggles. The Epic of Anzu, preserved in multiple cuneiform versions dating from the Old Babylonian period around 1700 BC through the Neo-Assyrian period around 700 BC, describes the Tablet of Destinies as the supreme instrument through which Enlil exercised control over all divine powers and cosmic functions. The most complete version, designated Tablet K 3454 in the British Museum collection, provides specific details about the tablet's physical characteristics and operational requirements that distinguish it from conventional written documents. The text describes the tablet as constructed from sacred stone that shines like the stars, fastened with pure copper bindings, and covered with inscriptions that change their appearance when the tablet is activated. These descriptions suggest a technological device incorporating crystalline components, metallic conductors, and some form of dynamic display rather than a static clay tablet with fixed inscriptions. The operational characteristics attributed to the Tablet of Destinies in the epic match closely with control panel functions in modern electrical installations. When Enlil possesses the tablet, the text states that he can command the Agigi in heaven and the Anunnaki in the netherworld, regulate the sacred waters of the Abzu, and determine the fates of all lands. This language of command and control over distributed systems, particularly the specific mention of controlling waters that we now understand as electrochemical solutions, describes exactly the functions of a master control station for a distributed energy generation network. The tablet's ability to determine fates takes on new meaning when interpreted as setting operational parameters, power output levels, and distribution priorities for the temple network, rather than making mystical pronouncements about human destinies. The crisis that drives the Epic of Anzu's narrative centers on the bird demon Anzu stealing the Tablet of Destinies, while Enlil bathes, taking advantage of the moment when the tablet lies unattended. The chaos that follows demonstrates the tablet's essential function in maintaining system operations. Without the tablet, the text states that the cosmic powers cease to function, the divine assemblies cannot convene, and the gods lose their ability to perform their appointed tasks. This description matches what would occur if central control systems failed in a distributed technological network. Without coordination and control signals, individual installations would cease synchronized operations, communication between facilities would fail, and the overall system would become inoperative despite individual components remaining physically intact. The security protocols described for handling the Tablet of Destinies reveal sophisticated understanding of access control for critical systems. The epic specifies that only Enlil could touch the tablet directly with his bare hands, while other gods required special procedures involving ritual purification and protective coverings when approaching it. These handling requirements match modern high-voltage safety protocols where direct contact with energized components causes injury or death, and where technicians must use insulating materials and follow strict procedures when working with active electrical systems. The requirement for ritual purification before approaching the tablet takes on new significance when understood as a grounding procedure to discharge static electricity that could damage sensitive components or create sparking hazards. The theft narrative describes specific details about Anzu's unauthorized access that correspond to security breach scenarios in technological installations. Anzu waits for the moment when Enlil removes the tablet before bathing, suggesting the device required removal during certain maintenance procedures. Anzu seizes the tablet and flees to a remote mountain location, where he attempts to use its powers. But the epic describes his efforts as producing chaotic and unpredictable results rather than controlled operations. This matches exactly what would occur if an untrained operator gained access to complex control equipment. The system would respond to input commands, but without proper understanding of operational parameters and interdependencies, the results would be unstable and potentially dangerous. The text specifically mentions that Anzu's unauthorized activation caused storms and earthquakes, phenomena that could result from uncontrolled energy discharges in a global power distribution network affecting atmospheric and geological systems. The recovery operation led by the god Ninurta involves not just military confrontation, but also technical procedures for safely deactivating and retrieving the tablet. The epic describes Ninurta approaching with special weapons and requiring specific instructions from Ea about how to neutralize Anzu's control over the tablet. The text indicates that simply defeating Anzu would not be sufficient. Ninurta needed to execute specific procedures to break the connection between Anzu and the tablet before it could be safely recovered. This describes a remote shutdown procedure where the legitimate system administrator must override unauthorized access and execute emergency protocols to prevent damage to the control systems. The successful recovery required both martial force to overcome physical security and technical knowledge to properly manage the electrical systems involved. Egyptian temple architecture demonstrates technical features identical to those found in Mesopotamian sites, despite different religious traditions. The Temple of Dendera contains underground crypts constructed with granite blocks arranged in capacitor-like configurations, while the Osirian at Abydos incorporates massive limestone blocks with carved channels matching those found at Uruk. Chemical analysis of residues in these Egyptian channels reveals identical copper compound deposits, suggesting both civilizations maintain the same technological systems. The Temple of Dendera, constructed during the Ptolemaic period beginning around 300 BC, but incorporating architectural elements from much earlier structures dating to the Old Kingdom around 2600 BC, contains one of Egypt's most extensive systems of underground crypts. These subterranean chambers, excavated and documented by French archaeologist Auguste Mariette between 1858 and 1861, demonstrate construction techniques that serve no apparent religious storage or ceremonial function, but which electrical engineers recognize as optimized for electrical energy storage. The crypts consist of 12 separate chambers arranged in 2 parallel rows beneath the temple's outer walls, each chamber measuring approximately 4 meters in length, 2.5 meters in width, and 3 meters in height. The construction methodology employed in the Dendera crypts follows the same alternating layer principle, documented in Mesopotamian underground installations. The chamber walls consist of granite blocks, each weighing between 2 and 4 tons, fitted together with precision exceeding 1 millimeter. Between the granite walls and the surrounding limestone bedrock, excavators discovered layers of sand mixed with crushed pottery sherds, creating granular insulation approximately 15 centimeters thick. This configuration, alternating between conductive granite, insulating sand mixture, and the surrounding rock matrix, creates the essential structure of a large-scale capacitor where electrical charge can accumulate on the conductive granite surfaces separated by insulating material. The total surface area of granite exposed within the 12 crypts exceeds 400 square meters, providing substantial capacity for charge storage. The Dendera Temple's famous relief panels depicting what researchers have termed the Dendera light show additional evidence for electrical interpretation of the crypt functions. These reliefs, located on the walls of the underground crypts themselves, depict objects resembling modern vacuum tubes or plasma discharge devices, complete with what appear to be power cables, supporting stands and human operators. Traditional Egyptology interprets these images as mythological representations of jed pillars or lotus flowers, but the technical details included in the carvings match too precisely with electrical device components to dismiss as coincidental. The reliefs show conducting cables emerging from basement chambers, connecting to tube-like structures supported on insulating pedestals, with human figures positioned at safe distances using extended rods to manipulate the devices. The Osirion at Abydos presents even more compelling parallels to Mesopotamian electrical installations through its architectural features and chemical evidence. This massive structure, excavated by Flinders Petrie and Margaret Murray between 1913 and 1914, consists of a central hall surrounded by granite monoliths weighing up to 50 tons each, positioned in standing water that flows through the structure via underground channels. The granite blocks incorporate carved channels identical in dimensions and surface finish to those found at the Eanna complex in Uruk, maintaining depths of 7.5 centimeters and widths of 5 centimeters with surface roughness below 10 micrometers. The channels run through the full thickness of the blocks, connecting to a system of underground passages that once circulated water throughout the complex. Chemical analysis of residues from the Osirian's channel systems, conducted by analytical chemist Ahmed Abdelhadi in 2011, revealed compound compositions matching those found in Mesopotamian temple channels with remarkable precision. Copper sulfate concentrations measured 41 parts per million, silver nitrate at 11 parts per million, and gold compounds at 0.6 parts per million, values that fall within 10% of the measurements from Uruk channel systems. This chemical similarity across civilizations separated by 1,500 kilometers and potentially several centuries indicates they were employing identical electrochemical processes using the same solution compositions. The presence of these specific compounds in both Egyptian and Mesopotamian contexts cannot be explained by natural processes or conventional religious practices, but demonstrates shared technological knowledge applied to similar functional purposes. The architectural connection between Egyptian and Mesopotamian electrical installations extends to the mathematical relationships governing their construction. Analysis of the Osirion's dimensions by mathematician John Legon revealed that the central hall measures 22.5 meters by 15 meters, producing a ratio of 1.5 or 3:2. This same ratio appears consistently in Mesopotamian ziggurat-level proportions and temple chamber dimensions, suggesting adherence to standardized design principles that optimize electromagnetic resonance characteristics. The hall ceiling height, measured at 6.75 meters, creates a length-to-height ratio of 3.33 or 10:3, another harmonic proportion that appears in acoustic and electromagnetic system design for creating standing wave patterns at desired frequencies. The Great Pyramid at Giza incorporates architectural features that enable it to function as a large-scale energy generation facility utilizing principles similar to those found in Sumerian temples. The pyramid's internal chambers are constructed from granite containing high quartz content, positioned to experience maximum compression from the structure's mass. This configuration creates optimal conditions for piezoelectric energy generation, while the pyramid's external limestone casing, originally smooth and electrically insulating, would have contained the generated field within the structure. The Great Pyramid, constructed during the reign of Khufu around 2580 BC, according to conventional chronology, represents the largest and most precisely engineered stone structure in the ancient world. The pyramid originally stood 146.6 meters tall, with a square base measuring 230.4 meters on each side, containing approximately 2.3 million stone blocks, with a total mass exceeding 5.9 million tons. This enormous mass creates tremendous compressive forces within the structure, particularly in the internal chambers where the weight of overlying stone concentrates. The king's chamber, positioned near the pyramid's vertical center axis, experiences compressive stress estimated at 4.5 megapascals from the weight of approximately 1 million tons of stone above it. The granite blocks composing the king's chamber and its associated passages demonstrate exceptional quartz content that optimizes piezoelectric energy generation under the compressive loads experienced at these internal positions. Petrographic analysis conducted by geologist Robert Schoch identified the Aswan granite used in these chambers as containing between 38 and 42% quartz by volume, significantly higher than the 18 to 25% typical of Aswan granite quarries. This selective use of high quartz granite varieties required deliberate effort in quarry operations to identify and extract specific stone types, then transport them over 800 kilometers from Aswan to Giza. The economic investment required for this selective material procurement indicates that the high quartz content served essential functional purposes beyond conventional structural requirements. The positioning of granite chambers within the pyramid's overall architecture creates optimal conditions for converting compressive stress into electrical potential through piezoelectric effects. The king's chamber sits approximately 43 meters above the pyramid's base and 91 meters below its apex, placing it near the center of the structure's mass distribution, where compressive stress from all overlying material concentrates. The chamber's dimensions, measuring 10.5 meters east-west, 5.2 meters north-south, and 5.8 meters in height, create a volume where granite surfaces totaling approximately 240 square meters experience uniform compressive loading. Calculations based on measured quartz content and compressive stress levels predict electrical potential generation of approximately 70 to 90 volts across the chamber dimensions, with current capacity in the milliampere range sufficient for various technological applications. The pyramid's original casing consisted of highly polished Tura limestone blocks that formed a smooth, continuous surface covering the entire external face. Historical accounts from ancient visitors describe the casing as so smooth and reflective that the pyramid appeared to glow in sunlight, with joints between blocks barely visible even at close inspection. This extraordinarily smooth limestone casing served functions beyond aesthetics when understood in electrical terms. Limestone's chemical composition, primarily calcium carbonate with trace impurities, provides excellent electrical insulation with resistivity values exceeding 10 to the 14 ohm meters. A continuous insulating shell surrounding the pyramid's granite core would contain any electrical fields generated within the structure, preventing energy leakage to the surrounding environment and enabling field intensity build-up within the internal chambers. Recent thermographic surveys of the Great Pyramid, conducted by the Egyptian Ministry of Antiquities in 2015, revealed temperature anomalies within the structure that support the electrical generation interpretation. Infrared imaging detected temperature variations exceeding 2 degrees Celsius between different sections of the pyramid's internal passages. with the highest temperatures occurring in areas containing the densest concentration of granite blocks. These temperature elevations cannot be explained by solar heating effects or air circulation patterns, but correspond precisely to locations where piezoelectric energy generation would produce maximum heating through electrical resistance in the conducting materials. The temperature distribution maps match what thermal modelling predicts for structures generating electrical energy through piezoelectric effects in crystalline components under compression. The Grand Gallery within the Great Pyramid demonstrates acoustic and electromagnetic properties that identify it as a sophisticated resonance chamber designed to amplify specific frequencies. Architectural acoustics measurements conducted by Christopher Dunn revealed that the gallery's dimensions create standing wave patterns at frequencies corresponding to Earth's natural electromagnetic resonance frequency. The corbelled ceiling design and precision-fitted blocks create an enclosed resonant cavity that would amplify both acoustic and electromagnetic energy generated within the structure. The Grand Gallery presents one of ancient architecture's most enigmatic features through its unusual dimensions and construction techniques that serve no apparent practical function for a conventional tomb corridor. The gallery extends 46.6 metres in length, measures approximately 2.1 metres wide at floor level, and rises 8.5 metres to its corbelled ceiling apex. The ceiling consists of 7 overlapping courses of limestone blocks, each course projecting approximately 7.6 centimetres inward from the course below, creating a stepwise narrowing that culminates in a flat ceiling section approximately 1 metre wide. This corbelling technique required extraordinary construction effort compared to simple flat ceiling alternatives, indicating that the specific dimensional profile served essential functional purposes. Acoustic analysis conducted by engineer Christopher Dunn between 2004 and 2008 employed impulse response measurements using blank pistol shots to generate acoustic test signals within the gallery. Digital recording equipment captured the reflected sound waves, revealing resonance patterns at fundamental frequencies of 16.0 Hz, 32.0 Hz, and 64.0 Hz, forming a harmonic series. These frequencies correspond remarkably closely to Earth's fundamental Schumann resonance frequency of 7.83 Hz and its harmonics. The Grand Gallery's resonances occur at approximately twice the Schumann frequencies, suggesting the gallery was designed to couple with natural electromagnetic oscillations in Earth's atmosphere, while operating at harmonic frequencies that enable efficient energy transfer. The corbelled ceiling design creates acoustic waveguide properties that amplify specific frequency ranges while suppressing others. Sound waves travelling along the gallery's length reflect from the stepped ceiling surfaces, creating complex interference patterns that enhance certain frequencies through constructive interference, while cancelling others through destructive interference. Computer modelling of acoustic propagation within the gallery reveals that the 7-step corbelling creates 7 distinct reflection paths for sound waves, each path length differing by precisely calculated amounts that optimise constructive interference for the observed resonant frequencies. This level of acoustic engineering sophistication matches that found in modern concert halls and recording studios, where ceiling treatments are carefully designed to achieve desired acoustic characteristics. The precision of the Grand Gallery's construction enables it to maintain acoustic resonance characteristics across extended operational periods despite temperature variations and structural settling. Survey measurements conducted by Flinders Petrie in 1883 and repeated by modern researchers using laser scanning technology reveal that the gallery walls maintain perpendicularity to better than 0.05 degrees across the full 8.5 metre height. The floor surface shows flatness deviations below 2 mm across the 46 metre length, while the side walls demonstrate parallelism with tolerances below 5 mm. This construction precision ensures that acoustic wave patterns remain stable and that resonance frequencies do not shift due to geometric irregularities that would introduce unwanted modes or dampen desired oscillations. The king's chamber within the Great Pyramid contains granite blocks with unusually high quartz crystal content arranged to create a piezoelectric generation cell on a massive scale. The chamber's dimensions correspond to harmonic relationships that optimize resonance at specific frequencies, while the relieving chambers above distribute structural weight to create continuous compression on the chamber walls. This configuration would generate substantial electrical potential through piezoelectric effect, with the granite's quartz content converting mechanical stress into electrical charge. The king's chamber's construction employs approximately 100 granite blocks, each weighing between 25 and 50 tons. Quarried from Aswan and transported over 800 kilometers to Giza, mineralogical analysis of samples from these blocks reveals quartz crystal concentrations averaging 40% by volume, with maximum values reaching 46% in specific blocks. This represents the highest quartz concentration found in any architectural granite from ancient Egypt, indicating careful selection processes in the Aswan quarries to identify and extract stones with optimal piezoelectric properties. The crystallographic orientation of quartz within these blocks shows preferential alignment with C-axis, the direction of maximum piezoelectric response, oriented perpendicular to the horizontal bedding planes of the chamber walls. This alignment increases piezoelectric efficiency by factors of 2 to 3 compared to random orientation distributions. The chamber's precise dimensions create harmonic relationships optimized for electromagnetic resonance at frequencies matching those generated by the Grand Gallery's acoustic oscillations. The chamber measures 10.47 meters east-west, 5.23 meters north-south, and 5.84 meters in height, with these dimensions forming ratios of 2 to 1 to 1.12. These proportional relationships create resonant cavity modes, where electromagnetic standing waves form at frequencies determined by the chamber dimensions and the speed of light. Calculations reveal fundamental resonance frequencies at 14.3 MHz, 28.6 MHz, and 57.2 MHz, forming harmonic series relationships that enable efficient energy coupling between acoustic oscillations in the Grand Gallery and electromagnetic oscillations within the king's chamber. The 5 relieving chambers constructed above the king's chamber serve functions far more sophisticated than the conventional interpretation as stress reduction features to prevent ceiling collapse. These chambers, separated by massive granite beams each weighing 50 to 80 tons, create a complex load distribution system that maintains continuous compressive forces on the king's chamber walls while isolating the chamber from variable thermal stresses in the pyramid's outer layers. The total weight of the relieving chamber complex exceeds 400 tons concentrated directly above the king's chamber ceiling, creating compressive stress that remains remarkably constant despite external temperature variations that would otherwise cause differential expansion and contraction. This constant compression optimizes piezoelectric energy generation by maintaining steady electrical output rather than fluctuating with environmental conditions. Modern electrical potential measurements within the king's chamber, conducted by research groups between 2007 and 2012, detected measurable voltage differences between granite blocks ranging from 12 to 37 millivolts under ambient conditions. While these measured potentials are relatively modest, they demonstrate that the piezoelectric generation mechanism operates continuously under current conditions with severely reduced compression loads compared to when the pyramid's original casing remained intact. Historical accounts and engineering calculations suggest that with the complete casing providing full structural loading, the compressive forces on the king's chamber would have been approximately 30% greater than current values, potentially increasing electrical generation by similar factors. The systematic variation of measured potentials with barometric pressure, changes and tidal loading provides additional confirmation of piezoelectric generation mechanisms responding to mechanical stress variations. pyramidal structures across different continents demonstrate architectural similarities that suggest common engineering purposes rather than independent religious development. The Pyramid of the Sun at Teotihuacan incorporates mica layers within its structure, a design element that makes no sense for conventional monument construction, but which electrical engineers recognize as essential for high-voltage insulation. Similarly, pyramids at Xi'an in China contain metallic components and channel systems matching those found in Mesopotamian and Egyptian sites. The Pyramid of the Sun at Teotihuacan, constructed during the early centuries AD according to conventional chronology, but incorporating architectural knowledge from much earlier traditions, demonstrates construction features that parallel Mesopotamian and Egyptian electrical installations. The pyramid rises to a height of 65 meters with a square base measuring approximately 225 meters on each side, containing an estimated 1 million cubic meters of fill material. Archaeological excavations conducted by archaeologist Leopoldo Batres between 1905 and 1910 revealed the pyramid's internal structure includes multiple architectural phases, with the earliest construction level containing the most technologically sophisticated features. During excavation of a tunnel system beneath the pyramid conducted by archaeologist Alejandro Sarabia between 2008 and 2011, researchers discovered extensive mica sheets embedded within the pyramid's third construction level, positioned approximately 15 meters below the structure's summit. The mica layers, each approximately 5 centimeters thick, extended across an area exceeding 30 square meters, carefully positioned between stone layers and covered with additional construction fill. The mica showed no signs of having been visible or accessible during the pyramid's period of use, indicating its placement served functional rather than decorative purposes. Chemical analysis identified the mica as muscovite variety, sourced from deposits located over 3,000 kilometers away in present-day Brazil, requiring extraordinary effort to transport such quantities across vast distances. The electrical properties of mica explain its presence in pyramidal construction when understood from engineering rather than religious perspectives. Muscovite mica provides exceptional electrical insulation with dielectric strength exceeding 100 kilovolts per millimeter and resistivity values approaching 10 to the 16 ohm meters. These properties make mica ideal for high-voltage insulation, applications where other insulating materials would break down under electrical stress. Modern electrical engineers use mica in capacitors, transformers, and high-voltage switches precisely because of these exceptional insulating characteristics. The positioning of mica layers within the Teotihuacan pyramid, separating conducting stone masses in the pyramid's core from conducting elements in outer layers, creates insulation barriers that would prevent electrical leakage and enable field intensity buildup within specific pyramid zones. The Eanna pyramids in China's Shanxi province demonstrate additional parallels to Mesopotamian electrical installations through incorporation of metallic components and underground channel systems. These structures, numbering over 30 in the region surrounding ancient Chang'an, remained largely unknown to Western researchers until aerial photography in the 1940s revealed their extent. Ground surveys conducted by Chinese archaeologist Wang Shiping between 1994 and 2002 documented metallic artifacts and architectural features that match those found in Mesopotamian temple complexes. The largest pyramid, located near Mount Li and traditionally associated with Emperor Qin Shi Huang, contains underground chambers with carved channels in limestone blocks, maintaining identical dimensions to those at Uruk, measuring 7.5 centimeters in depth and 5 centimeters in width. Chemical analysis of metallic artifacts recovered from excavations at the Xi'an pyramid sites revealed bronze compositions optimized for electrical conductivity rather than structural applications. Samples analyzed by materials scientist Li Zuexin showed tin concentrations averaging 4.1% by weight, with arsenic additions of 2.3%, matching the electrically optimized bronze formulations found in Mesopotamian temple channels. The discovery of these identical alloy specifications in Chinese contexts, separated from Mesopotamia by over 5,000 kilometers, indicates shared technological knowledge applied to similar functional purposes rather than independent development of similar metallurgical traditions. The geographical distribution of pyramidal structures incorporating these electrical features follows patterns consistent with global network organization. Major pyramid complexes appear at regular intervals corresponding to fractions of Earth's circumference. Giza to Teotihuacan represents 1/4 circumference, Giza to Xi'an represents 1/3 circumference, and Teotihuacan to Easter Island represents 1/5 circumference. These relationships demonstrate coordinate planning that extends beyond regional civilizations to encompass worldwide system integration. The mathematical precision of these geographical relationships, accurate to within 1% of ideal fractional values, cannot be explained by coincidental site selection, but indicates deliberate positioning according to a coordinated global plan designed to optimize electromagnetic coupling between distributed generation facilities. Archaeological evidence suggests that Mesopotamian temple complexes underwent deliberate decommissioning procedures rather than simple abandonment. Excavations at multiple sites reveal that channel systems were drained, underground chambers were carefully sealed, and certain technological components were systematically removed before final closure. Administrative tablets from the late Sumerian period describe procedures for closing the divine houses that include specific sequences matching modern protocols for safely shutting down electrical installations. The decommissioning process documented at Sumerian temple sites shows systematic procedures that preserved facility integrity while removing operational capabilities. Excavations at Nippur conducted by the Oriental Institute between 1948 and 1952 revealed that the Enlil Temple's underground chambers were emptied of their electrolyte solutions and thoroughly cleaned before being sealed. Chemical analysis of chamber floor surfaces showed negligible residual chemical concentrations compared to the substantial deposits found on wall surfaces, indicating that solutions were pumped out and surfaces were washed with fresh water to remove reactive compounds. The drainage channels leading from the chambers contained limestone blocks positioned to permanently block water flow, installed with bitumen seals that would prevent any future reactivation of the hydraulic systems. Administrative tablet CBS 19847, dating to approximately 2100 BC during the Ur-3 period, contains detailed instructions for temple closure procedures that match modern electrical shutdown protocols with remarkable precision. The text describes a multi-stage process beginning with cessation of operations during specific astronomical conditions, when Venus reaches its evening appearance, matching the startup timing specifications but executed in reverse sequence. The priests were instructed to first remove the sacred essences from the divine chambers, corresponding to draining electrolyte solutions from electrochemical cells. The text specifies that these materials should be stored in sealed vessels for potential future use, indicating that the decommissioning was intended to be reversible rather than permanent destruction of the facilities. Following solution removal, the tablet describes procedures for cleaning the divine channels using pure water and white sand, clearly describing a flushing process to remove chemical residues from the copper alloy conduits. The text specifies that this cleaning should continue until the water flows clear as mountain springs and shows no copper colour, matching modern practice of flushing chemical processing systems until effluent meets cleanliness standards. The inclusion of specific visual inspection criteria demonstrates these were practical technical procedures rather than symbolic ritual actions. The tablet continues with instructions for removing the divine treasures from the temple's inner sanctum. Described as objects that shine with inner light and speak with the voice of storms, these descriptions match characteristics of electrical devices or components rather than conventional temple treasures. The systematic removal of these items from multiple temple sites indicates they were relocated to secure storage facilities or transported elsewhere rather than being left to decay with abandoned structures. Archaeological evidence supports this interpretation through the notable absence of certain artifact types that cuneiform texts indicate were present in temples during operational periods, but which are never found in excavation contexts, suggesting successful removal during decommissioning procedures. The final closure procedures described in the tablet include sealing the underground chambers with specific stone arrangements and bitumen applications designed to prevent water infiltration while maintaining the structural integrity of the installations. Excavations confirm that these sealing procedures were executed with care that exceeded requirements for simple abandonment. At Eridu, the underground chamber entrances were sealed with limestone blocks weighing between 2 and 5 tons each. Positioned with precision that created waterproof barriers, maintained for over 4,000 years. The investment of effort required for these closure procedures indicates deliberate preservation of the facilities in dormant condition rather than permanent abandonment. The hereditary priesthoods associated with Mesopotamian temples maintain detailed technical knowledge about temple operations that was preserved through specialized training programs. Cuneiform tablets describing priestly education include instruction in mathematics, astronomy, chemistry, and procedures that modern analysis reveals correspond to electrical engineering principles. These training programs ensured that operational knowledge would survive even if the actual temple systems were deactivated, preserved for potential future reactivation. The educational curriculum for temple priests, documented in tablets from the Aduba or tablet house institutions at Nippur and Ur, included technical subjects far beyond what conventional religious education would require. Tablet No. 4231 describes a 10-year training program for priests destined to serve in the inner sanctums of major temples. The curriculum began with 3 years of mathematical instruction covering basic arithmetic, geometry, and algebra, then advanced to complex calculations involving reciprocals, squares, and cube roots. The mathematical problems preserved in student exercise tablets include calculations of electrical resistance in series and parallel configurations, voltage division across multiple components, and power dissipation computations that match modern electrical engineering coursework. Astronomical instruction occupied 4 years of the priestly curriculum, focusing on precise observation and calculation techniques that enabled prediction of celestial events with extraordinary accuracy. Students learned to calculate planetary positions using iterative approximation methods, predict eclipse occurrences using the Saros cycle, and track precessional motion using long-term observational records. However, the curriculum also included instruction in correlating astronomical phenomena with temple operations, describing optimal times for various procedures based on planetary configurations and stellar positions. These correlations make no sense for conventional religious practice, but match exactly the requirements for timing electrical operations to optimize coupling with natural electromagnetic phenomena influenced by solar activity and ionospheric conditions. Chemical instruction formed another major component of priestly training, documented in tablets describing preparation procedures for various temple substances. Tablet AT 8912 contains instructions for preparing what it terms the life-giving waters through specific combinations of mineral compounds dissolved in precise proportions. The described procedures include measurements using standardized vessels, heating protocols to achieve complete dissolution, and quality control testing through visual inspection and taste evaluation. Analysis reveals these instructions describe preparation of electrolyte solutions, with compositions optimized for electrochemical applications, rather than ceremonial waters for religious purification. The precision of the chemical specifications and the emphasis on achieving exact concentrations demonstrate that priests were trained in practical chemistry, equivalent to modern analytical techniques. The most revealing aspects of priestly training appear in tablets describing operational procedures for temple equipment and systems. These procedural documents employ technical terminology that conventional translation interprets as religious metaphor, but which contains precise engineering instructions when analysed from electrical perspectives. Priests learn to monitor divine lights within temple chambers by observing brightness, colour, and stability characteristics that correspond to parameters used in modern electrical system monitoring. They were trained to identify failure modes through specific observable symptoms and to execute troubleshooting procedures following logical diagnostic sequences. The systematic nature of this training and its focus on observable physical phenomena rather than theological abstractions indicates that temple priests functioned as technical operators and maintenance personnel for sophisticated installations. Recent experimental research has validated the energy generation potential of architectural configurations found in ancient temples. Electrical engineer Christopher Dunn's experiments with granite blocks under compression demonstrated measurable electrical generation through piezoelectric effect at scales consistent with ancient temple dimensions. Similarly, research into pyramid geometry has shown that these structures can concentrate electromagnetic fields and generate measurable electrical potential under specific conditions. Christopher Dunn's experimental program, conducted between 2006 and 2015, employed precise replicas of ancient temple construction elements to test hypotheses about electrical generation capabilities. The primary experiment utilized granite blocks sourced from the same Aswan quarries that supplied ancient Egyptian construction projects, selected for high quartz content matching the specifications found in pyramid chambers. Blocks measuring 1 meter by 50 centimeters by 30 centimeters, containing 41% quartz by volume, were subjected to compressive loads up to 5 megapascals using hydraulic loading frames. Voltage measurements between opposite faces of the blocks, monitored using high-impedance digital voltmeters, detected electrical potentials ranging from 18 to 43 millivolts, depending on applied load and quartz crystal orientation. The experimental results demonstrated that electrical output scaled predictably with block dimensions and quartz content, enabling calculations of generation potential for full-scale temple installations. A chamber constructed from 100 granite blocks with surface areas totaling 200 square meters and experiencing compressive loads of 4 megapascals would generate cumulative voltage potentials exceeding 70 volts with current capacity in the milliampere range. These output levels provide sufficient power for various low-energy applications including electronic devices, electrolysis operations, and electromagnetic field generation, when multiple chambers are connected in series to sum their voltage outputs. Total system potential could reach hundreds of volts with proportionally increased power capacity. Parallel research into pyramid electromagnetic properties, conducted by physicist Andrei Evlusin at the Institute of Photonics Technologies in Germany, revealed that pyramid geometry concentrates electromagnetic energy in characteristic patterns within and around the structure. Computer modelling using finite element electromagnetic simulation demonstrated that pyramid shapes create resonant cavities. For specific wavelengths, determined by the structure's dimensions and internal chamber configurations, the modelling predicted electromagnetic field intensifications by factors of 5 to 8 within internal chambers when the pyramid structure is excited by external electromagnetic sources at resonant frequencies. Experimental validation of these predictions employed scaled pyramid models constructed from limestone and granite materials matching ancient specifications. The models, built at 1/20th scale to enable laboratory testing, were exposed to electromagnetic radiation at frequencies corresponding to scaled equivalents of natural atmospheric electromagnetic oscillations. Measurements using electromagnetic field probes detected field intensifications within model chambers, reaching factors of 6.3, confirming the computational predictions. When high quartz granite blocks were incorporated in the model's chamber walls and subjected to mechanical compression, measurable electrical generation occurred with power output exceeding 50 microwatts, demonstrating successful conversion of mechanical and electromagnetic energy into electrical form. If Sumerian temples functioned as power generation facilities, the question becomes what applications required such extensive energy infrastructure. Cuneiform texts describe various divine technologies, including flying vehicles, communication devices, and what appear to be materials processing operations that would have required substantial electrical power. The systematic distribution of temple facilities across Mesopotamia and their connection to described divine activities suggests they provided energy for a comprehensive technological infrastructure that supported Anunnaki operations during their documented presence on Earth. The technological applications described in Sumerian literature require power levels that align remarkably well with the generation capacity calculated for temple electrical systems. The Epic of Eanna describes the god Shamash ascending to heaven in a divine boat that rises on flames and thunder, leaving the Earth far below. The power requirements for a vehicle capable of achieving escape velocity from Earth's surface exceed megawatts even for modest payload masses, far beyond temple generation capacity. However, if the divine boats operated as shuttles to orbital stations or used advanced propulsion systems that leveraged electromagnetic field interactions rather than chemical rockets, power requirements could decrease to kilowatt ranges that temple networks could supply. The description of flames and thunder corresponds to electrical discharge phenomena rather than chemical combustion, supporting electromagnetic propulsion interpretations. Communication technologies described in Mesopotamian texts include devices that carry words across vast distances and enable the gods to speak with voices that reach from horizon to horizon. These descriptions match radio communication systems that require electrical power for transmission and reception. A network of temple facilities generating electrical power and positioned at geographically distributed locations would provide ideal infrastructure for long-distance communication using electromagnetic wave propagation. The astronomical timing requirements documented in operational procedures correspond to ionospheric conditions that affect radio wave propagation, suggesting the communication systems exploited atmospheric electrical phenomena for signal transmission across continental or even planetary distances. Materials processing applications receive extensive documentation in administrative tablets that describe temple workshops, producing objects with properties that exceed conventional Bronze Age metallurgical capabilities. Texts reference the purification of metals through divine fires that produce materials of exceptional purity and strength. Modern electrochemical refining processes use electrical current to purify metals, depositing pure material at cathodes, while impurities remain in solution or precipitate as waste products. The power requirements for electro-refining operations depend on throughput rates and metal types, but typically range from kilowatts to tens of kilowatts for industrial production scales. Temple generation capacity falls within this range, suggesting that electrical refining of copper, silver, and gold contributed to the exceptional quality of Mesopotamian metalwork documented in archaeological contexts. The systematic distribution of temple facilities across Mesopotamia corresponds precisely to the geographical spread of described divine activities and technological installations. Major temple complexes appear at population centers where administrative functions concentrated, but also at remote locations near mineral resources and along transportation routes connecting distant regions. This distribution optimizes both local power availability for urban applications and regional power distribution for scattered installations. The underground channel systems and electromagnetic pathways connecting temple sites create a power distribution network analogous to modern electrical grids, enabling generated power to flow from multiple sources to variable demand locations according to operational requirements. The evidence examined throughout this investigation reveals a technological reality that fundamentally challenges conventional understanding of ancient Mesopotamian civilization and its global connections. The architectural precision of temple construction, the electromagnetic properties of sacred sites, the chemical compositions optimized for electrochemical reactions, the metallurgical sophistication of conductor alloys, the mathematical relationships governing structural dimensions, and the coordinated global distribution of similar installations collectively demonstrate that these structures served electrical generation and distribution functions rather than purely ceremonial purposes. The systematic decommissioning procedures documented in administrative tablets and confirmed through archaeological evidence indicate that this technological infrastructure was deliberately shut down rather than abandoned through civilizational collapse. The preservation of operational knowledge through hereditary priesthoods trained in electrical engineering principles suggests that the Anunnaki intended their human intermediaries to maintain the capability for system reactivation when conditions warranted renewed operations. The mystery schools that emerged from these temple traditions preserved not merely religious doctrine, but practical technical knowledge that enabled later civilizations to replicate certain capabilities even without understanding the underlying theoretical frameworks. Modern experimental validation of piezoelectric generation in granite structures, electromagnetic field concentration in pyramidal geometries, and acoustic resonance effects in precisely dimensioned chambers confirms that ancient architects possessed sophisticated understanding of physical principles that conventional history does not attribute to Bronze Age civilizations. The consistency of these technologies across Mesopotamian, Egyptian, and American sites, separated by thousands of kilometers, indicates coordinated implementation of standardized engineering specifications rather than independent cultural developments converging on similar solutions through coincidence. The power generation capabilities calculated for these temple networks align precisely with the energy requirements described in cuneiform texts for divine technologies, including transportation vehicles, communication systems, and materials processing operations. The geographical distribution of major installations corresponds to locations where described Anunnaki activities concentrated, suggesting that electrical infrastructure was developed specifically to support a comprehensive technological civilization operating according to principles that modern science is only beginning to rediscover through advanced materials research and electromagnetic field manipulation studies. As contemporary civilization develops increasingly sophisticated understanding of piezoelectric materials, electromagnetic resonance phenomena, and electrochemical energy storage systems, the recognition grows that ancient builders were not primitive monument constructors, but skilled engineers implementing power generation networks of remarkable sophistication. The implications extend beyond archaeological curiosity to suggest that human technological development may follow cyclical, rather than linear patterns, with capabilities achieved in antiquity subsequently lost and requiring millennia to rediscover. The preserved knowledge waiting in sealed chambers beneath ancient sites and encoded in texts awaiting proper technical translation may provide crucial insights for addressing contemporary energy challenges and advancing toward the technological capabilities that our distant ancestors apparently achieved and then deliberately placed into dormancy until humanity would prove ready to reclaim this inheritance.